This is a projectile question, and we have a projectile launched from the top of a cliff with a height versus time function given by this. We want to know the average velocity from a time of 1 second to a time of 4 seconds. We want to know the instantaneous velocity 6 seconds after the launch, and we want to know the velocity at the moment the projectile strikes the ground. And I'll just add a little question mark there. Well, the way we're going to find the average velocity between t equals 1 and t equals 4 is to figure out the heights at those times, and we do that by subbing it into the original formula. After 4 seconds, the height is 240.1 meters, and after 1 second, the height is 196 meters. Well, using some grade 9 basic linear concepts, we see that the average velocity, in other words, the average rate of change, is y2 minus y1 over x2 minus x1, which is 14.7. So the average velocity from t equals 1 to t equals 4 is 14.7 meters per second. And in this context, the implication is that that's in an upward direction. Now, we want to know the instantaneous velocity at a time of 6 seconds. In order to do that, we need to take the derivative. So taking the derivative of that height function, we get h prime t equals negative 9.8t plus 39.2. We can then figure out the derivative value when t equals 6. And we get a value for the derivative of negative 19.6. In this context, that's like saying 19.6 meters per second downwards. Finally, we want to know the velocity when the projectile strikes the ground. Well, the ground has a height of 0. So that means that h of t is going to equal 0. We set that quadratic equal to 0, and we factor, and we get a t value of either negative 3 or positive 13. Well, in this context, we're going to use the time of 13 seconds. So we want to determine the value of v prime at 13. V prime at 13 equals negative 88.2. So the velocity when the projectile hits the ground is negative 88.2 meters per second, or in other words, 88.2 meters per second downwards.